Okay, just as a review, this is nothing new to you. Just to kind of review, you're trying to get this x plus 3 quantity squared. You want to get that by itself. And so obviously we would start by adding 12 and then dividing by 4. Now once you get the x plus 3 quantity squared by itself, then it's time for a square root. And you don't want to forget your plus and minus, right? We know the square root of 100 is plus and minus 10, right? In a solving situation, you have to have both answers. And then to get the x by itself, you subtract 3. And 10 minus 3 is 7. And, that's the first one. And negative 10 minus 3, that's the negative 13. Those are the two answers to that question. But that's just review. Now, how do I take this thing and factor it? Well, remember, they have to multiply together to give me 25 and add up to 10. So that would be x plus 5 and x plus 5. That's the same thing as saying x plus 5 quantity squared. And it's really important that you understand that when you have two things that are exactly the same, you do want to write it as something squared, which means that the original thing right there is a perfect square. It just happens to be the perfect square of a binomial, and since it's got 3 terms, we call it a perfect square trinomial. So what's this one going to factor into? X minus 7, which is x minus 7 squared. Now, I do want to find out if you can see a connection between this positive 10 on the linear x and the positive 5 in the parentheses, which is the exact same connection that we have between this negative 14 and that negative 7. I'm hoping that you will see that the connection I'm referring to is half. You took the linear term, cut the linear term, the linear coefficient in half. That's literally all we're doing. Now, before we get all to this magic number stuff, let's see if we can use the exact same logic and do what we were talking about a few minutes ago. Maybe we don't need a magic number. Maybe if we just understand that half of this number is going to be like this, x plus 10, and this would be x plus 10 quantity squared. Now, what is 10 times 10? 100. So to find the number, to find this number, I take the two numbers that were which came from this, right? We just took half of it and then we multiplied it times itself. So if we do that same logic on the next one, what's half of negative 8? Well, that would be negative 4. If you take negative 4 times negative 4, you know that this was a 16. And we know that we can write that x minus 4 squared. On this one over here, we could write x minus 3 halves, x minus 3 halves. Now, for you decimal fans out there, that's the same thing as x minus 1.5 times x minus 1.5. Now, math teachers like to see their fractions. That would be x minus 3 halves squared. Now, what number am I adding in there? What is 3 over 2 times 3 over 2? Isn't that 3 times 3 on the top and 2 times 2 on the bottom? 9 over 4. Yes, I know that's 2.25. So some kids might say, well, 2.25 is the decimal. Folks, if the decimals get weird, you're going to want to stick with fractions, because the fractions won't be that bizarre. Now, do I need a magic number? No, I don't need a magic number. So I'm going to ignore the magic number for now. If we absolutely need a magic number, we can come back to that. But magic numbers, if we know the process is half the linear term and then square it, I mean, that's really what they're going to tell you in that magic number anyway. So before I go through any instructions that you see up above, let's just kind of talk through this and see if we can do this without any magic instructions or magic numbers. Now, I don't know who in their right mind set this up because they didn't leave me enough room. So I'm going to slide that over. Now, if I use what I know, what I did before, right? X plus 4, right? Because you're taking half of that number times x plus 4, which is really the same thing as x plus 4 quantity squared. 4 times 4, that's 16. If you add 16 to the left side, you got to add 16 to the right side. Well, what is 20 plus 16? That's 36. And then, of course, whoops, I can take the square root of both sides, giving me x plus 4 equals plus and minus 6. And then we can subtract 4 to the other side to get my correct answer. 6 minus 4 is 2, and negative 6 minus 4 is negative 10. Now, could I have done that a different way? Yes, but if you're asked on a test, to do the process called completing the square, you will lose a large amount of credit if you do it a different way. So, I got x squared minus 9x plus blank equals negative 19 plus blank. If we know that this is x minus 9 over 2 times x minus 9 over 2, that's x minus 9 over 2 squared. But what is 9 over 2 times 9 over 2? Isn't that 81 over 4? 81 over 4. I know you decimal fans out there are going nuts right now. You're like, what? 81 over 4? Why didn't he just say 20.25? Right? Because we know that's the same thing as 20.25. Well, it'll probably be a nice number here when I get done. So, if I convert this into fourths, that's negative 19 times 4 on the top there, plus 81 over 4, or, let's see here, that's negative 76 plus 81. What is negative 76 plus 81? Isn't that 5? And yes, folks, if you do these two things together, you do get 1.25, which is 5 over 4. So, square root, x minus 9 over 2 equals plus and minus. We got square root 5, and then what is the square root of 4? Oh, that's just a 2 on the bottom. And so, of course, that's going to move to the other side and give me 9 over 2 plus and minus the square root of 5 over 2. Don't worry about ugly decimals. And I'm probably going to try to stick to the fractions on that because they'll look a lot nicer than the ugly decimals. So yes, you do have to remember things like, how do I convert negative 19 into 4/4. Okay, so yes, take me back to my middle school days kind of thing. All right, let's see how we're going to handle this next part. Probably the same way we're handling it before. So x squared plus 12x plus blank equals negative 40 plus blank. All right, so x minus 6, right, because you take half that value, which gives me x minus 6 quantity squared. And then, of course, we know that negative 6 times negative 6 is 36. So that's what's going to get added to both sides. So we now have negative 4 over here. Okay, now it's time to take that square root. X minus 6 equals, remember our plus and minus, but since there's a negative under the radical, that's going to give me 2i. Don't forget to bring that from the other side, 6 plus or minus 2i. And no, I don't need to, number one, I can't even combine those two things together. That's as good as it gets. Right there, 6 plus or minus 2i. So let's look at that next one. X squared minus 4x plus blank equals negative 49 plus blank. All right. So let's see here. That's, we take half of negative 4, that's x minus 2, right? X minus 2, we want them both to be the same. But that could only happen with negative 2 times negative 2, which is positive 4. And of course, you copy it to the other side because you can't do it to one side without doing it to the other. And then that would give me negative 45. And then it's time for my square root, which I know this is going to be split into square root 9 and square root 5, right? Because remember, you're looking for a perfect square and then extras. But the perfect square, the largest perfect square, which goes into 45, is 9. But the negative always goes with it. Plus, we know it's going to be plus and minus, so it's 3i, and then that square root 5 is left. It's an extra. Of course, the other side was x minus 2. And then, of course, we can move this to the other side by adding it. Oops, why did I put 2i when it's 3i radical 5? So x equals 2 plus or minus 3i radical 5. We always like to put the real part first and the imaginary part second. Just like a complex number. Complex numbers always have real first, imaginary second. Yes, I know technically you could flip it around, but you won't see any mathematicians writing it like that. Okay, that's enough notes for this lesson.